Hello students, this is the section Measures of Center from the chapter Numerical Series of Data. In this unit, we're going to learn, or in this video, we're going to learn how to compute the mean, the median, the mode, how to compare the median and the mode, and we're going to approximate the mean when we have group data in the form of a frequency distribution, and we're going to practice computing a weighted mean. I would like to start first with the definition of mean. You already know this as average. It's when you find the sum of all the numbers in your sample or in your data set and then divide by the total count of them. We're going to be using this symbol, the X with a bar on top, to denote the sample mean, and the mu Greek letter to represent the population mean. And just so you know, we are going to round the mean to one more decimal place than the data. So if you have your data in whole numbers, your data set, you're going to round to the first decimal place. If you have your data set with 3 decimal places, you're going to round to 4 decimal places, and so on. Let's take this data, for example, the one that we have been using, the one that was the list of students' heights in a statistics class. If we were going to compute the mean for this data, we have to add all of our values and then divide by the total. We had a total of 24 values, and once you add them up, divide by 24, we get that our mean is 1.5616666666. Because we want to round our data to one more decimal place than our data set, because we want to round our mean, one more decimal place on the data, we're going to round 1.561666 to 1.562. Our data set had values with 2 decimal places. Our mean will have 3 decimal places. Of course, if you're giving different instructions on your question or on your assignment, if you're being asked to round to 4 decimal places, feel free to do so and round to 4 decimal places. Now, we're not gonna be telling you add all the values and divide by the total count. We're going to be using a formula, and to be able to understand the formula for the mean and the formula for the following computations that we're going to cover in the following units, I need you to be familiar with the notation of summation. Let's suppose you have a list of n values, and we're going to list these values as x1, x2, x3, x4, x5, all the way to x sub n. Each value is represented by an x with a superscript. We're going to use the symbol sigma, which is a Greek letter, to represent sum. And this is how we're going to write the sum of all of the x values. Summation of x, or sigma x, will be representing the sum of all of those n values. To distinguish between the sample size and the population size, because we're denoting both with the letter n, we're going to use lowercase n to represent the sample size and uppercase n to represent the population size. Right now, because we're only covering mean, it seems a little bit unnecessary, but eventually for the following units, we're going to cover the formulas on how to compute the standard deviation, the variance, and the lowercase and uppercase letter will help you distinguish between the population and sample formulas, and will help you understand which formula we're using or which data set are we calculating the mean or the standard deviation or variance for. So if we're using this notation, this will be the formulas for the sample mean and the population mean. Remember those symbols? We use the X with a bar on top to denote sample mean, and we use mu, which is kind of like a cursive M, to denote the population mean. For both, you have to add all of your values. If you want to write a summary formula, it will be the sum of all the x values divided by n, which represents the count of those x values. Similarly, the population mean is the sum of all the X values in your population divided by the count of values in your population. Now, how does the mean measure the data? Well, the mean is the point where the data set will balance if each value were represented by an equal weight. We're going to think of this as the value that if you add to your data set, it will maintain everything the same. Your data will still have a very similar distribution, and your data will remain having the same mean. Okay, now the next measure of center for this section will be the median. It's the number that splits your data set exactly in half. This value, it's different for a data set having an odd count of values and a data set having an even count of values, because you have to split your data exactly in half. The steps for computing the mean is arranging your data values in increasing order, then determining the count of values, and now we have two options. If you have an odd count of values, your median will be the number exactly in the middle. If your data set has an even count of values, you have to find the mean of the two middle numbers. There was an in there. Okay, and I hope I can help you represent the difference between the two in the following drawing. The median splits your data set exactly in half. Let's suppose we have an odd number of values. We have 5 values. If we want to split our data in half, 2 values will fall to the left, 2 values will fall to the right if we choose the third value. But if we have an even set of an even number of values, if in order for me to split it exactly in half, I need to find a value in between the 2 middle ones. That's why you calculate the mean of those 2 middle numbers. And by calculating the mean, we mean adding them up and dividing by the count, or adding them up and dividing by 2. Let's take the same data set that we were working with, and this time we want to find the median. Our first step will be to arrange our data values in increasing order from least to greatest. And then if you notice, our data is even because the top 2 rows represent the first half and the bottom 2 rows represent the second half, which means I have a value in between these two that would be considered my median. I'm sorry that right here it looks in rows. It should be a straight line, but I don't have enough space on the screen. So if I wanted to calculate the median, I'm going to take the average of these two numbers and that will be the median number. We're going to add them and divide by 2. 153 plus 155. Oh, I skipped a step. We have an even number of values. We have 24. So we have to follow that step of taking the average of the 2 middle numbers. 153 plus 155 divided by 2 gives me 154. This is my median, 1.54. Now, we can describe our data just by being given the mean and the median, even if we don't have all the data values or if we don't have a graphical representation or graphical summary for it. This will be the relationship between the mean and the median. If your data set is skewed to the right, then we have that the median is to the left of the mean, or the mean is to the right of the median. You can choose to remember the mean is to the right because our data set is right skewed. So if you say right skewed, the mean is to the right, it will be easier for you to see it. And on your assignments, you should be asked to draw conclusions from this. So let's suppose you have your data set being right skewed, and you know that your median is 25. There's a lag. The median is 25. Knowing that it's right skewed and the median is 25, what conclusion can you draw from this if you know that the mean is noticeable greater than the median? Well, it means that the mean falls to the right and the mean is greater than 25. Sorry, I put it the way around. The mean is greater than 25. Now whenever you have a bell-shaped distribution, our mean and our median are approximately equal. They're very close to each other. If you have a left-skewed distribution, your mean is to the left and your mean is noticeable smaller than the median. Now, a common question that you could be posing yourself, which one's better? Which one do we choose to use, the mean or the median? Each of them had their advantages and disadvantages. The pros from the median will be that it takes into consideration every value in your data set. You're not only using the two middle values like we do for the median, we're using all of the values and then finding the value that could balance the data set. The disadvantage or the con from the median would be that one very large value or one very small value will affect it, and it would make it maybe not as representing from the data set. Take for example, whenever you are calculating your grade for a course or for a portion of the course, if you have 300s but then you get 1 0, your average sinks. Now, the pros from for the median would be that it's not influenced by extreme values. You can have a very large value or a very small value in your data set, but because we're only taking into consideration the two middle values, our median is not affected by those extreme values. But a disadvantage is in the same token that it depends on the middle values only, or just the middle value. Take for example, I'm going to explain this one right here. Take for example that our data set is 1, 2, 3, 4, 5 1s and 1 8. Our data set looks like it's an even count. So if I want to split my data in half, my median would be in the middle right here, and I have to add these 2 1s and divide by 2. 1 plus 1 divided by 2 is 1, so my median is 1. If you notice, it's not accurate representing of the center of your data set, because your data set ranges from 1 through 8, and your median in this case, because it only takes into consideration the two middle values, would be just 1. Okay, now I want you to take a pause in this video and try to calculate the mean, the median of the following data set for the first question, and then I'll go and discuss with you the second and third questions. If you were calculating it by hand, you first need to arrange your data set values from least to greatest to calculate the median, only for the median. This is a very common step forgotten, so feel free to make a note on your notebook saying, do not forget to arrange your values from least to greatest. When I was a student, it was very common that I would just take these two values, add them, and divide by 2 if I had an even count of values. So if I rearrange them, now I have 35, 47, 55, 74, 89, and 93. Now they're from least to greatest. We have an even count of values. I have to add 55 plus 74 and divide by 2. That's how you find the median. And to find your mean, you have to add all of these values, 74 plus 89 plus 35 plus 93 plus 55 plus 47, whatever that gives you, you're going to divide by 6 because we have a total of 6 values. For calculating the mean, you don't have to have them in increasing order, or you don't have to have a particular arrangement of your dataset values. Now, I'm going to take advantage of this checkup question, and I'm going to show you how to calculate the mean and the median using Excel. We're going to type our dataset. I'm going to type 74, 89, 35, 93, 55, and 47. I have a count of 6 values: 74, 89, 35, 93, 55, and 47. Okay, let me zoom in a little bit. To calculate your mean, I'm going to choose this cell to put the answer for the mean, and if you want to, you can label it. And I'm going to calculate the median. The mean you calculate with the command equals, and then you're going to type average. You can click on it here, or you can type it and then open a parentheses. You select your data set range. If you know the cell numbers, you can also type them here, B4 all the way to B9. Then hit enter. That would be my mean. To calculate the median, you start again by putting the equal for saying command, and then you start typing median. You can click on it, or you can type the whole median word and then open the parentheses. You could select a range, or you can type your values if you want. I'm going to close the parentheses and type enter. My mean for this data set is 65.5. My median is 64.5. This is how you calculate your mean and your median in Excel. Now for our second question. It says, a family survey reports that the mean number of children in families or in a family is 2.1. Someone tells you that this must be wrong because a family cannot have 2.1 children. Why would this be? Feel free to pause this video and think about your answer, but let's discuss it. Remember on our early slides, one of our early slides, whenever we introduce the mean, we normally round our mean one more decimal place than the data. If you collected the number of children from families to calculate this mean, our data set was of the form whole numbers: 0, 1, 2, 3, 4, 5, only whole numbers. Because we calculated the mean and although you got a decimal number, we're going to round to one more decimal place. So it had to do with the rounding of the mean. Now for our last question, I want to draw it. I'm going to put it in a new slide. A data set has a mean of 5 and a median of 7. So a mean of 5 and a median of 7. The median is greater. Would you expect this data set to be skewed to the right, skewed to the left, or approximately symmetrical? Because our mean is to the left, then it would be left skewed. Our tail will be to the left. Sorry, try to make it more left skewed. There you go. Left skewed. This will be our answer. Now for our last measure of central tendency, or the measure of center, we're going to have the mode. The mode is not really a measure of center because it could be any value. It could be the first value, it could be the last value, it could be on the first half, second half. And the mode would be the value that appears the most in your data set. Think of the popular value. I hope you guys remember from last section, graphical summaries of data, the stem and leaf. This is an example of a stem and leaf, and it's very easy to find which one is our mode when you have your data in the form of a stem and leaf representation. If you notice, we have the value here, 1.63 being repeated the most with 4 times. This will be your mode. There's a few advantages of the stem and leaf graph in comparison with the other graphs. One of them is that you can pinpoint the mode very easily. Now, you have 3 different possibilities when you're computing your mode. You could have one mode, you can have multiple modes, or you can have no mode. One mode will be just you having one value that repeats the most. Multiple modes will be when you have more than one value, 2 or more, that are tied up for the most frequent. And no mode will be when no value repeats more than once, or no more value repeats more than the others. All of your values repeat twice, all of your values repeat 3 times, and so on. If you wanted to compute the modes of the following data, because these are data sets, it's very easy to compute it. You can just take a look at the values, and if you notice over here we have the value number 1 repeating 4 times. This will be my mode. For the second data set, we have 4 2 times and 6 2 times. We have multiple modes. This is multimodal. Multimodal data. You have the modes 4 and 6. And for your last one, we have 74, 89, 35, 93, 55, no mode. None of the values repeat more than once. Okay, now how do we compute the mean when we have group data? Meaning that you have your mean already arranged or represented in a frequency distribution, which is a table with the count of each values. We don't have our raw data. We don't have the values. I only know that I have, for this frequency distribution right here, I only know that I have 13 values from 1 to 10. And then I know I have 18 values in between 11 and 20. And then I have 5 values in between 21 and 30, and so on. I have no values between 41 and 50. How can I compute the mean if I don't know my data set numbers? I just know their frequencies and from a class. We have multiple steps. Let's do them one by one. First, you will find the midpoints for each class. And I hope you remember from the previous classes. If not, let me show you. To find the midpoint, you're going to add the lower class limits for your class and the next one. 1 plus 11 is 12, divided by 2, and you divide by 2. You add them, and then you divide by 2. 1 plus 11, 12, divided by 2, 6. Then we have 11 plus 21, that's 32, divided by 2, 16. And you keep on doing that process until you finish your table. 21 plus 31, 52, divided by 2, 26. And then once you find a pattern, you can just keep on going. It's 16, 26, 36, 46, 56. Which means our class width will be 10. There's a lag in the Wacom. Now that we compute our midpoints, we're going to multiply the midpoint times the frequency. In other words, we're making up a similar data set, a very similar data set. I know I have 13 values in between 1 and 10, so I'm going to make up 13 sixes because it's exactly the midpoint. And I'm going to do that by multiplying them. 6 times 13. And then the midpoint for the second class is 16. I'm going to multiply it times the frequency. Now I'm going to have 18 16s. And so on. You're going to do the same thing for every class. You're going to multiply the midpoint times the frequency. Once you have all of those values multiplied, you're going to find the sum. This will be, in other words, the sum of all of your values because these are the values we made up. And we're going to divide the sum of the midpoint times the frequency by the frequencies. We're going to divide 660 by 40. It gives me 16.5, which means my approximate mean, make sure you use the approximate symbol, will be 16.5. Why is it approximate? Because we do not know which ones are the values within our classes. We created midpoints to estimate those values. And our last definition for today will be the weight mean. The weight mean is calculated by multiplying all of your data set values by an assigned weight they have. Some numbers will count more than others, and then you just multiply each of the values, the data values, by their weights, add them up, divide by the total number of weights. That's how you calculate the weighted mean or the weight mean. Just so you know, fun fact, this is how your GPA is calculated. Depending on the course credits and your score, it's how you're going to calculate your grade. If you have a class that has 4 credits, the grade for that class is going to count 4 times more than a class that has only 1 credit. Let's suppose, for example, that I have, I don't know why you have this here. Let's suppose that I have this grades, this grades for these courses. You have an A in statistics, a C in English, an A in music, and a B in psychology. And the credits for each course are 5, 3, 2, and 4. I'm just giving up this information here because it was given in the example. But let's take to be A worth 4 quality points, B worth 3 quality points, and C be worth 2 points. It could be different. Your question is going to give you the weights for each of the data values. You don't always have to use 4 for A, 3 for B, and 2 for C. Please read the instructions in your problem. This was already given to me. This was given to me. Now let's calculate the weight mean. I'm going to change each of these values, like A will be 4 points, C will be 2 points, A will be 4 points, and B will be 3 points. Now I'm going to multiply those points times the credits. This will be, in other words, the weights of my values. Let me write it down better. We're going to multiply 5 times 4 and add it to 3 times 2 and add it to 2 times 4 and add it to 4 times 3. And then we're going to divide by the total sum of the weights. It looks like the GPA for this particular person that had this scores, this grades, is 3.29. How do I get rid of this in the back? Okay. Now, I would like you to practice with the following slides, calculating the mean and the mean for group data, either in Excel or in Google Sheets. I went a little bit on how to calculate the mean. Remember, you use the command average. The median, you use the command median. And I didn't show you the mode. Let me try to go and show you the mode. For mode, you'll put equal and then mode. You're going to click on multiple ones just in case it gives you multiple modes, and select your data range. It says not apply because none of your values repeat more than once. If you were to choose the mode singular, this one, it will only, if you have multiple modes, it will still only give you one mode. Okay, here's the data sets that I would like you to use to calculate the mean. Remember to use the command equals average, and I would like you to create your distribution tables with the midpoints, with the frequency times the midpoint, so you can calculate the mean for this group data sets. You can just choose one, just pick one and calculate the mean, and then calculate the mean for calculate the sums and then calculate the mean for each of the group data sets. Now, just so you know, I included here a new definition. I want you to find the modal class. The modal class will be just the class that has the most values, the class with the highest frequency. And you don't even have to do computation for that. For the first data set, which one is the class that has the highest frequency? 15 to 29. This is your modal class. For the second data set, we have that from 10 to 19, we have 15 values. No other class has more values than that. 10 to 19 will be my modal class. That's how you calculate the modal class, just by looking at it. Thank you so much for watching this video. I hope you get to practice using either Excel or Google Sheets for your calculator, and have a very good day. Bye.